Hey, good afternoon, guys. I don't hope you all fall asleep now because you have lunch. And this is about enterprise software. And enterprise software is just notoriously boring, right? It's like whenever you hear about people working for an enterprise software company, everyone is going, oh my God, they're just sitting there making phone-based screen capturing data and putting it back into a database. But in reality, there's tons of stuff going on behind the scenes when you're working in an enterprise software company. I've been in the enterprise ERP space for the last 12 years. And I think in my career, spanning nearly 25 years now in software, these have been the most interesting years in my career. And there's a lot of challenges. The next time you see an opening in an enterprise software company, just don't turn it away on it because it sounds boring. It's actually very interesting. So what I'm going to talk about here is not so much the machine learning part, like what's deep learning algorithms about and all that stuff. There's a lot of coverage of that. But what I would like to cover is what it took for us as a company that has specialized in developing enterprise software to capture the data so you can actually get to the point where you can start applying machine learning and any other kind of AI techniques that you wanted to use. And we have an interesting challenge compared to if you are a business that have your own solution in where you actually know the data, you know where the sources are coming from. We don't always know that. We honestly we have no remote chance of knowing all permutation of configuration of our software when it's out at the customer, even in a cloud setting, because it's highly configurable. But we wanted, and then second is that what we wanted to solve, and this is what I'm using for this presentation, is that apart from being dull, enterprise software sucks. Right? Have a very bad user experience. It actually can hurt your retina just looking at some of the screens, and they're very complex. So what we have seen is a transition. So we had like web interface. We went from web to mobile, and each of these transitional steps giving birth to either a less complex platform on which you can run your application. And remember, much of the software is traditional run on fat clients. And you move to mobile devices where you then saw all of a sudden a lower real estate on the screen. And now we're looking at digital assistants. And each of these transitions meant that users would be presented with tons of information in different various ways that not necessarily were very good. And what we did as vendors in this space was we just trying to give them the exact same, they have to enter the exact same amount of data regardless of where they were on the device, meaning if you had an enterprise interest screen, I'll show one in a short while, you could just cram down on a phone, not very good. And if you want to do the digital assistant, it becomes even more complicated. And we just launched the digital assistant. So what we are seeing is that the user interface complexity, and you come over to application intelligence, where applications should be able to do more on their own. At the same time, we of course build these kind of softwares, but there's also a change going on there. There's a transition going from this kind of monolithic architecture that's not really very great to work in. It takes a long time into what we call more microservice-based, right? And why is this interesting? I'll come to that in a point. But essentially, this is also driving the number of data sources you typically see, because each of these have their own data sources, and they may not even have the same data model. So what we wanted to do was to create a better experience for users. So we have something like this. This is it's not really that bad, but this is something users that enter time is used to deal with, right? So you have all these fields that you have to enter, and guess what? All these fields have dependency. So depending on which one you pick, some of these can change. There can be business rules. There's validation rules. So it can be actually a kind of challenging to enter time in here. And essentially, what you really want to do is just to say to Wanda, which is our digital assistant, please log 40 hours on Wanda or some development project. And then you honestly want the software to figure all this stuff out on their own, right? You don't want to deal with that. It's not very nice. And think about if you have an experience like this, then it's going to come out and ask, could you please give me the work order? Could you please give me the project? Could you please give me the activity? That's a very bad experience from a chatbot. So we came up with the idea of building what we call the Dimensional Prophecy Service. Short, DIMPS, not a very good acronym. But so we really wanted to be able to look at all this data, all these dimensional fields, And not to go into too much details about an ERP, everything is dimensioned. There are some specifics dimensions you capture, like activity, work order, and so forth, and they form up a structure inside the ERP solution, so you can go find it, and you can find it in your ledger and all that good stuff. But we really wanted to be able to use whatever users inputted to find out what is the highest probability of what is shown when you enter like wonder, oh, this is the activity code, this is the project code, this is the type of hours. So that's all great and good. So we had all these different things floating out in our data space, right? So we had these monolithic application that we all know and we all hate. We had new set of microservices and everything. And we had this bright idea, okay, we'll put DIMS into this, right? And, dimensional prophecy service. Great. So you can go look at all these different applications to find out. Because if you look at our product portfolio, we have, for time registration, we have like 3 different solutions offering that, and we have a microserving offering back office service to do it as well. So we actually had like a number of different services giving you the same capabilities, but guess what? There was not the same APIs, there was not the same data model, there was just nothing. There was like, oh my God, this is nearly an end problem, right? Because you have to rewrite a lot of this stuff every time for each data source. So you got different APIs, you have different data models, you have different perspective on historical data. And if you want to know what users did before, you need historical data. Guess what? A lot of these solutions, they don't even care about history. They just store the latest transaction, and then boom, you're off. You forgot about history. I have no history. So we needed to find a way to get hands on all this information. And supplementary application offering similar capabilities, and they're not all multi-tenant. That means that then all of a sudden, if you have 3,500 customers, they have all different data sources. So that's a lot of data you have to go, and a lot of API call, and a lot of sources. So what we came up with was that we want to try to find out a way we could change this. So we started down the path of using messaging for this. So we found out that messaging was a good way of actually creating a data could flow in as messages from the different source system. So they could all feed in there, and they could go into the data lake, and that's great. We have all the data in the data lake, and the DIMS could go down there, have one API, everything coming in. But again, well, that's fine, but the data is not uniform. It's different data models, the dimensional structure, everything could be different. So there's a ton of work that still needed to be done in that end. So because you had to kind of transform the data each time you wanted to run anything on top of it. So in order to solve that, there was kind of a number of ways you could do it. You could either solve it down in this box and have it kind of go through and grant all the data and press out a new data structure, or we could go back and say, well, we really want to make sure that the data that comes into the data lake is well-defined, such that we can build more generic algorithms that can work across all our users, so we didn't have to do a lot of after configuration, or what we refer to as post-installation implementation work. So in order to do that, we decided to build what we call an ontology. So an ontology is simply a way to describe the data model if you have disjoint data structures, and we put that inside. We want to put that into the data lake, and it's typically also referred to as a canonical data model. So the good thing about this canonical data model inside is that then you all of a sudden have a well-defined data format for your disparate solutions. So you can then go in for time and define a timesheet, because we call these enterprise documents. Inside these enterprise documents, which are all JSON-based, you then have a standard definition, standard defined set that allows you to understand, regardless of where the data source, regardless of the data source and where the data originate from, you can then have the dimension and definitions, and hence you can then go and look at activity, you can go look at, and this is the same that comes in from all systems. So it gives you this nice, great, unified picture of the data structure coming in from multiple sources. So this is all great and good, right? So now we had the enterprise documents. We had this depicts like two different two application offering time capturing and then a time and expense microservice. They all produce timesheet enterprise documents that go into the data source. So that's really great. So now at least we had a way and a definition so that we didn't have to go and have n number of input sources. We didn't have to go and have a deal with like 6 or 7 different data models. We actually left it to the applications to make sure that they supplied the data in the right data model into a data lake on which we then could base our future machine learning algorithms. So that's all nice and good. And here we see it depicted a little different, sends it out unchanged. But the problem is, when we looked at all our applications, not a lot of old legacy monolithic application understand the concept of an enterprise service bus or Azure service bus or Windows service bus or any bus of that matter. They have no clue what this is all about. They're not used to operate with that. They simply just write data into a database and then they go happily after. So we needed to find out, to get the data from these solutions. And that was actually an interesting challenge we were up against there, because when you have these big monolithic applications, they, due to the way that they're developed, due to the massiveness of them, whenever you want to change anything in them, you have to go through a long, tedious software development life cycle. And I don't know if any of you are familiar with this kind of application, but you have like 12 months, 18 months of development life cycles. Not very agile, which means that if you want to put something in here, it takes forever before it actually hits the street. So we were, and in other cases, you find that they don't really have the necessary APIs around them. A lot of these, API first is a new construct. Some of these applications are 20, 25 years old. Some of the code is 20, 25 years old. So there's a lot of legacy in there. And you can't just go rewrite it because we are talking thousands of man years of work. So we needed to come up with a way that we could, going forward, we could actually enhance the applications without having to go through this long development life cycle and wait for it to come out in the other end. And at the same time, be able to maintain the investment there are in these applications. Because as you can imagine, this is a massive amount, and there's a lot of good functionality inside the monolith, as we refer to it here. So what we came up with was something we called the embracer pattern. And the embracer pattern, like this picture, embraces the application. But it's not like it's encapsulating in a new runtime or anything like that. It's actually presenting this new service layer where you can then put in the access logic, bidirectional logic for getting data out of the solution, getting data back into the solution. And you can have it. It can have its own life cycle, and it will use these services, like the one over there, will then use on the back end of it. Will use whatever API is available. In some cases, there are some maybe SOAP-based APIs. There may be some lower-level coding techniques, RPC or something like that. You can use and exploit to get the data out, or it can go access it from the database. The idea is that on the backside of them, you can even load in runtime code from the legacy if you need that, if you have some business rule and validation like to repurpose. But on the outside, it has this new, well-defined API on a REST-based JSON API that's governed, so we have a unified way to actually get into all our applications. So by having these embracers around the different applications, that typically were centered around specific processes or workflows or tasks or domains, we then had the ability to roll out new enhancements to the application and continuously improve the APIs and make it easier to get the data in and out. And these could be shipped every month. So they get deployed. In our situation, we deploy them at every sprint. We can enhance it, give new APIs and new functionality. And in this case, these were the integration adapters. So they were then responsible for taking the data out and then put it into the data lake for the dimensional prophecy service then to actually go and execute the machine learning algorithm on it. The thing is that's all nice and good, right? But what we really wanted to do as well was that we really wanted to get the data when it happens. This is typically batch is used to get data in and out of these solutions, but we didn't want that. We wanted the data to come out nearly when it happened, when the action as a transaction changed, either on the transactional data itself or on the actual master data, there were changes. We wanted to get the data out. And here we had to go and bite the bullet, because how did we get to a point that data was streaming in and out of the monolith without having to go and create something in the monolith? And we couldn't, so we had to do that. So we came up with what we call the event processing. Most of you may know, in writing these applications, you typically, for the more well-architected, there's some that definitely don't have it, and then it becomes a little more complicated to deal with. They have a data access layer at the bottom. And the data access layer is solely responsible for writing data into the database and make sure there's transactional integrity, which is very great. But we then put in what we call the event processing layer as well. And the idea about the event processing layer is that, and the data access layer, is that by encapsulating them into one transaction, we could, whenever we write a transactional record down to the database, which is used in the business, we could also send out an event saying, yes, we actually made an update, or we made a create, or we made an insert or something. We could send out a very short message and put it on an internal bus or an internal queue. This is just a queue that was then going into the outside world. And then when we had that in place, we could actually then put in our integration adapter we talked about, using the APIs, the old legacy APIs into the solution, and the queue APIs to get the messages out. And then the integration adapter could use the APIs to actually go retrieve the data. So, for example, if you write a timesheet, if you go in and do your timesheets and you save this timesheet record to the database, it would send out a timesheet update or timesheet create. It is then the microservice would then go out, get the event, and then go retrieve the data by the means of the API, convert it into a enterprise document, and then put it onto the outbound bus, or in another queue that only concerns enterprise documents. Of course, in this particular situation, we don't put all the transactional data onto the queues, because if you work with like Azure Service Bus or Amazon queues or something like that, there is a limit to the size, and some of these transactional documents become pretty big. So what we did was that we only sent the event that something has happened on the queue, and then with a reference to the actual transactional document, and was then stored in a blob storage somewhere. So this is all, in our case, this is all Azure, so we all run on the Microsoft stuff. So we're using Azure Service Bus for that. So that left us then with this situation now. There was what we had before, right? We had all these different data sources coming in, everything flowing around, getting in from different sources. There was disjoint data models. There was no way we could actually go into a dimensional prophecy service. We had an experiment about 3 years ago where we built a specific service within the project management to go in and analyze if a project was going to derail. And what happened with that product was that due to the high configurability and the missing the consolidated data format, we weren't able to get it to succeed. We just simply couldn't get that project to succeed, because whenever it gets out to customers, they may have changed some things. So some of the attribute you were using to deduce from in the machine learning simply failed. So this was then all of a sudden history, and then we had this situation instead, which then became our reality, right? So we had different applications. They were all using the Embracer pattern to actually create small microservices that could access the legacy APIs or the databases or the legacy code to get the data out of the solution. They would create the JSON document, the JSON representation of the enterprise document or the transactional data. They would put it onto a bus, and then everybody could consume it, and everything went into the data lake, and then we could start looking at similarities between the dimensions in the different applications so that we could start creating this way better user experience and especially drive our conversational user experience by means of our digital assistant, but also create UIs, user interfaces that could also populate some of these more complex fields with respect for the underlying business logic. So everybody was happy, right? And that gave us this actually allowed us to take this screen, and we are currently running this with a customer in Norway. Take this screen, there was a typical enterprise timesheet screen, and then open up the access and giving the ability to go and get rid of these codes and then do everything by means of the digital assistant. So that was kind of like the journey to what it required from an architectural perspective and what are the changes we went through. So we spent about the best of like 2.5 years creating these new infrastructure. And so you can actually, by having a description of your data, you get to a position where it's way easier to actually have a meaning about your data, and you can create more generic algorithms to go look at it. So that was actually my presentation. So I think we have a lot of time for Q&A.